Okay, this week we're going to talk a little bit more about codominance. We talked about that already, when you have two dominant traits and then you get a third trait to show up. And we are also going to talk about making a pedigree chart. So this is your first objective for this week. I can describe how alleles can be codominant. Okay, when we start talking about human blood types, there's 3 alleles that code for blood types. Remember, codominant means that a third trait shows up. So we have 3 different alleles. So type A is written as capital I, capital A, because it's codominant. Type B blood is written as capital I, capital B, because it's also codominant. And then type O blood is recessive, so that is your lowercase letter. Remember, dominant traits are always capital letters, and recessive traits are always lowercase letters. Okay, so this is showing whether for each blood type, a heterozygous and a homozygous for type A and B. Because type A blood, because it's a dominant trait, it can be either homozygous, showing 2 capital letters, or it can be heterozygous, one of each. Because remember, if you have one capital, one lowercase, your dominant trait will always show up. Okay, so type A blood can be homozygous dominant or heterozygous. Type B blood can be homozygous dominant or heterozygous, right here. AB blood is both dominant. This is your third trait that is showing up right here, which is capital IA, capital IB. It's codominant, making that third type, which is AB blood. And then, of course, you have your recessive trait, which is type O, which is 2 lowercase letters. Remember, the recessive trait only shows up when there's no dominant trait around. Okay, this is just to show you, if you know what your blood type is, where you fit in. O positive blood, again, is the most prevalent. Remember, we talked about prevalence versus dominant. Just because O is prevalent doesn't mean it has to be dominant. O is a recessive trait, but it is prevalent. 38% of the population has type O blood. Okay, so we're going to go into making some Punnett squares. A woman with type O blood, which means lowercase I, and a man who is type AB, so capital IA, capital IB, are expecting a child. What are the possible blood types of this child? So we make our Punnett square, and we see here's our mom, lowercase I, and your dad, capital IA, capital IB, and then we go through and we multiply. Lowercase I times capital IA gives us capital IA, lowercase I, and we do that for all 4, and we find out that if we look at this, the number of kids that will be heterozygous with type A blood, we're looking for capital IA for type A blood. That will be 50%. And also heterozygous for type B blood. Here's type B, here's type B. That is also 50%. Make sure you fill that in on your notes. Okay, so just another example, possible blood types of a child whose parents are both heterozygous for B-type blood, which means they're going to be a capital IB and a lowercase I, both of them the same. We do the Punnett square. We find out that we have B-type, 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 75% chance that the child will be type B blood. And we only have the 2 recessive lowercase i's shown up one time, so 1 out of 4 is a 25% chance that the child will inherit type O blood. Okay? Some traits in your body, like your height and your skin color, are not controlled by a single gene. They're controlled by multiple genes. Your height is, they know, is controlled by 4 different genes. So you're not just going to have a tall gene or a short gene. One of the genes might be short and 3 of them might be tall. So it just depends. Your height is not determined by one gene. Okay? Same as your skin color. Okay, moving on to Objective 52, which is on pedigree charts. I can make a pedigree chart to determine how traits were passed down through generations. Pedigree charts are really helpful if you're trying to show a record of your family. It's the same as your family tree. So if we're talking about a pedigree chart and you use the word family tree, they mean the same thing. Pedigree charts are used to study the transmission of a hereditary condition, especially if you're looking at, some diseases that can be passed down, like Parkinson's disease or Alzheimer's. They're helpful to know if that might be something you face when you get older. And they're very useful when there's large families and a good family record over several generations. It's better if there are multiple children who then again have multiple children. If you have a family tree or a pedigree chart where it's just one child gets married, has one child, it's really hard to tell if there's a trait that's being passed down. Okay, on your guided notes you need to fill in the symbols for the different parts of what makes up a pedigree chart. So if you look here, your normal male is males are squares. Okay, so a normal male will be an open square, where your affected male will be a filled-in square. Females are circles. Normal female, open circle. Affected female is your shaded-in circle. And then if you have a circle that is connected to a square, that shows a marriage. So if you look over here at this example, you have a mom and a dad, and they had 5 children. Their oldest children is always listed to the left and youngest all the way to the right. So their oldest child is a girl, and then a boy, and then you have an affected boy for whatever trait it is that they're mapping. And their fourth child is a boy, and their last child is a girl. Okay? This is just showing organization of how it works. So if you look at this example, these would be the grandparents. These might be your parents. These could be your aunts and uncles. And then these are your parents. This is you and your brothers and sisters, and one of your sisters got married. Okay, and so that works. That's how that works. And so if this is your sister and she got married and then had a child, there would be a line coming down showing that your sister and her husband had a girl. Okay, so that's how pedigree charts are organized. And when we are looking at the organization of a pedigree chart, generations are identified by Roman numerals. So your grandparent generation, if that's the one you're starting with, that's Roman numeral 1. These are your parents and their your aunts and uncles, that's Roman numeral 2. And then this would be like your generation, which is Roman numeral 3. And then if you had children, that would be Roman numeral 4. And you could keep going. If your children then had children, that would be Roman numeral 5. So they keep going and going and going. Okay? Okay, so I'm just going to give you a quick example of a pedigree chart. Maybe I'm going to give you an example of a pedigree chart. Okay, so my mom married my dad, so a circle and a square. Together they had 4 children. My oldest sister, my brother, then me, then my little sister. Okay? My sister is married. My brother is married. I am married, and my little sister is married. My oldest sister has 3 children. Her oldest is a boy, her middle is a boy, and her youngest is a little girl. My brother also has 3 children. His oldest is a girl, then he has a boy, and then a girl. This is my family. I have 2 children. My oldest is a girl, and my son. And then my little sister also has 2 children. Her oldest is a girl, and her youngest is a boy. Okay? So if I start tracking, we'll say brown eyes, my dad has green eyes, my mom has brown eyes. Now brown is a dominant trait, but out of the 4 kids, only I got brown eyes. My sister has blue eyes, and her husband has green eyes. And then my brother right here, actually this is my brother. This is my brother here. His wife has brown eyes, and then I have brown eyes. And then my husband has green, and my little sister has blue, and her husband has blue. Okay, so right now we're tracking for brown eyes. If we look at the children, this is my oldest sister, and her husband. Their middle child, Joey, has brown eyes. Sean has blue. Leah has blue. If we look here, this is my brother and his wife. She has brown eyes. And their son and daughter both have brown eyes. And then this is myself and my husband, and our daughter has brown eyes, and my son has hazel eyes. And then my little sister, she has blue, her husband has blue, and Cameron ended up with brown eyes. Okay? Alright, so actually I think Jeremy might be green or hazel. Can't remember for sure. But anyway, if we're tracking for brown traits, then all of the filled in circles are showing you the ones that are affected by having the brown eye trait. Okay? So that is how you make a pedigree. Okay? You could make one for your own family and track whatever you wanted. That is it. 11 minutes is what you have for video notes this week. Ask questions in class if you have any.